The planet I chose was KOI-55c. KOI-55c is a planet that revolves around its parent star, Kepler-70, approximately 3,848.54 light-years from Earth. KOI-55c was discovered in 2011 using the exoplanet detection method of orbital brightness modulation. This is the idea that all exoplanets must emit a finite amount of light due to the light reflecting off of it from its parent star. Reflected light is recorded and used to locate and discover the planet. KOI-55c has a mass of about 0.655 of Earth's mass. To calculate its mass in kilograms, we just multiply 0.655 times the mass of Earth to find that the mass of KOI-55c is approximately 3.911 times 10 to the 24th kilograms. The radius of KOI-55c is about 0.867 of Earth. To find its radius in kilometers, we took Earth's radius of 6,371 kilometers and multiplied it by 0.867. This found the final radius of 5,523.66 kilometers. The temperature of KOI-55c is extremely high, reaching around 6,534 degrees Celsius. This is because of its close distance from its parent star, of approximately 0.0076 astronomical units. An astronomical unit is the distance between the Earth and our Sun. This is much closer to the Sun than our Earth. To find how close it is, we took one astronomical unit, which is approximately 149,597,871 kilometers, and multiplied it by 0.0076 to find a final distance between KOI-55c and Kepler-70 of approximately 1,136,943.82 kilometers. Because of its close distance to its parent star, the temperatures are extremely violent, and this planet is considered uninhabitable by any means. Kepler-70 is the parent star of KOI-55c. Kepler-70 is a star located roughly 3,800 light-years away in the constellation of Cygnus. Kepler-70 is a host to two planets. The planet I chose, KOI-55c, as well as KOI-55b. These both are Earth-like planets in size. Kepler-70 is currently a sub-dwarf star, and it is headed to become a white dwarf after it loses all of its helium in its core. It was a red giant approximately 18.4 million years ago. Kepler-70 is about 1/5 the size of the Sun, and it has a radius of 0.203 of our own Sun. To calculate its radius in kilometers, we took 0.203 and multiplied it by the Sun's radius to get 141,188 kilometers. The mass of Kepler-70 is approximately exactly 1/2 of our own Sun. To find the mass of Kepler-70, we take the mass of our Sun and multiply it by 0.496 to find 9.865 times 10 to the 29th kilograms. The temperature of Kepler-70 is about 5 times that of our Sun, at about 27,000 degrees Celsius. Here are the calculations for KOI-55c's orbital velocity and orbital period. First, let's start with KOI-55c's orbital velocity. I'll let K equal KOI-55c and S equal the host star Kepler-70. First, we start with Newton's second law in circular motion. This is acceleration. And we also use the universal laws of gravitation. Using substitution, we can say that since they're both equal to Fg, that mk times v squared k over rk is equal to the universal law of gravitation. Now we can cancel out the radius on the bottom and cancel out that squared and cancel out mass of k and mass of k on the other side. Then we are end up with velocity squared k equals the square root of g times the mass of Kepler-7d divided by the radius of KOI-55c. Using this equation and plugging in the gravitational constant, the mass, and the radius, we ended up with an orbital velocity of about 3,451,499 meters per second, which is an extremely fast velocity, especially compared to Earth's. Next, we move on to its orbital period. This is how long it takes to revolve the entire sun. So, we start with the simple velocity equals distance over time. Then we use circular in a full circle. This is the diameter. Velocity equals distance, which is also diameter, 2 pi rk over t. Plugging that in for substitution for velocity, as we use this, but we plugged in velocity, this for velocity, we get gravitational constant times ms divided by rk equals 4 pi squared r squared over t squared. As we continue simplifying, we end up with time equals the square root of 4 pi squared times the radius cubed divided by the gravitational constant times the mass of Kepler-7d, which is the host star. Plugging in all of those numbers, we end up with an orbital period of about 10 hours, which is close to its real orbital period, as some simplifying or rounding will be off a little bit. But these are the calculations for KOI-55C's orbital velocity and orbital. In conclusion, KOI-55C is much like Earth in its mass and size, but its temperature and many other factors are completely different than planet Earth.